In this lecture, we're going to pick up where we left off, and we're going to get into some of the more popular methods of sampling. And when I talk about sampling, I'm talking about obtaining units or cases from some population of interest. And we begin by what's called probability sampling. And with probability sampling, we have a method here that is not particularly systematic in any nature. And so every element in the population has an equal chance of being selected with probability sampling. And so the first concept here is what's called simple random sampling. And simple random sampling conceptually is if the sample is large enough, is an accurate representation of the population because every case, every element in the population has an equal chance of selecting. As an example of simple random sampling is what's called a table of random numbers. Now, these are found in research design textbooks, statistics textbooks. These can also be found on the internet by just copying and pasting table of random numbers, and you'll see images of those tables of random numbers. And by selecting those numbers randomly, all of the digits have an equal chance to occur, and the numbers are listed in a random manner, so they're not in numerical order. And two concepts related to simple random sampling. The first is called sampling with replacement. And what sampling with replacement means that is that after one unit or one case is selected from the population, it's put back into the population and it has an equal chance of being selected again. In contrast, sampling without replacement occurs after one unit is selected. That unit is not added back and it has no further chance of being selected. Now, in many research, in fact, I would say most research applications, the manner in which cases or elements are sampled from some population is not truly random. And so that leads us into what's called systematic sampling. And systematic sampling, as the term suggests, is about how to obtain samples in a very structured sort of way. And this occurs through a number of steps, and we'll get to these numerical values on the right hand side here shortly. And the first step with systematic sampling is to make a list of the accessible population. And so companies that engage in polling or customer satisfaction surveys by directly contacting people would use this approach. So the accessible population might be the residents listed in a 519 area code. And as an example here, suppose the population size is 50,000. That's what the researchers have to deal with. The first step is to determine an interval size. And so it's not feasible to obtain questionnaires from 50,000 people, but the systematic approach provides that way to have a reproducible method to obtain that sample. And the interval size is a ratio of the total population size, in this case the population we have to work with is 50,000, divided by the sample size. Now the sample size has to be determined ahead of time by the researchers, and the researchers in this example have decided that they want to begin with a sample size of 500 people out of the 50,000. So the interval is just simply the total population of that area code divided by the sample size, and that gives us an interval width of 100. The next step is to randomly select a number between 0 and the interval of 100, and that we call K. And so the researchers randomly selected number 41. So this is just a selection out of the table of random numbers or 100 units that the researchers would randomly pick from. And so, for example, they come up with 41. And then the next step is that every kth person in each interval, or every 41st person in each interval, is now the sample. And so what we see here is that we begin with the 41st person. That is the first case in the sample for the researchers. The next person that's sampled, or the next case that is sampled in this systematic manner, is that we take the next 41st person. So we take the 41, we add it, we add 41 to the 41, and we have to add 1 to move it up so that we have moved 41 units forward, and that lands us at number 83. We then move forward another 41, and we have the third person at 125. And so the number of respondents out of the 500 would end up being 119. And so a total number of the respondents divided by the sample size indicates that out of that initial sample size, we're obtaining almost 24% of the respondents in our sample. And so we see this pattern here on the right hand side, where if we start with 0 and then we move 41 units, so that's the first person, second, third, the 41st person is the first respondent out of our sample size. And following the same pattern here, we would initially start again where 41 becomes the 0 point, and we move to the next person and the next person, and that will end up at the 41st person, and then that is actually the 83rd person if we match up here. So by resetting the 41, as we can see on the right, to a 0, we can see that the next person is actually 42. That's why when we add 41 to the previous, we have to add 1 to it to ensure that our interval progressions are still the same. The next approach is to take what's called a stratified random sample. And so a stratified random sample is where the population is divided into subgroups. And so this could be separating males from females, university majors, and so this could also not just work with a population, but this could also work with a relatively large sample as well. And we begin with what's called a proportional stratified sample. And the proportional stratified sample separates the population of interest into different categories and then randomly selects a sample from each category. And the goal here is to create the same relative number of samples in each category. And so in this example, we take a first year psychology class. Now suppose we have, that becomes our population, and if our population here is 300, we have 300 students in that first year psychology class, and we make up 3 different categories. We have those students that are majoring in social psychology, we might have students that major in neuroscience, and then other majors. So we have 148, 97, 55. So we're dealing with a different number of units, cases, or people in these different categories. With a proportional stratified sample, it's proportional, and the goal is to obtain 50% representation from each of these 3 BA programs. Now, this number could be 60%, it could be 30%. It's really dependent upon the decision of the researchers. And so to obtain 50% from the social psychology students, we would have to have a sample of 74 students. we would have to have 49 students from neuroscience and 28 students from other majors. Because we have odd numbers of students in neuroscience and the other majors, we would just round up after dividing those two categorical samples sizes by 2. Now, the potential problem here with a proportional stratified sample is a statistical issue. And the statistical issue is that we have unequal or non-equal sample sizes. And so this does pose mathematical challenges from a statistics perspective. But there are statistical techniques that can adjust for these sorts of differences. Alternatively, we have what's called disproportional sampling, and disproportional sampling is performed with different sized populations with the goal of trying to create equal sample sizes. And the goal here is to have the same absolute number of samples in each category, in contrast to the previous slide where we had the same relative number of samples in each category. And we go with our psychology class once again with our 300 total students, 148 in social psychology, 97 neuroscience, and 55 other majors. And the researchers may decide here that they want to create a sample of 30 from each of these 3 categories. And so obtaining 30 students from social psychology, 30 from neuroscience, 30 from other majors, what we would find is that we've obtained 20% of the social psychology students of all the psychology students, 31% come from neuroscience, and 55% come from other majors. And so the potential problem with this approach is that the other majors category is overrepresented in this particular approach. So we see that with proportional sampling and disproportional sampling, there are some limitations with either approach, and it just depends upon the researcher's intention on what they wish to obtain from in order to answer their research question. Another type of sampling is called cluster sampling, and as the term suggests here, the population of interest is first identified and is then divided up into clusters or subgroups based upon specified criteria. And then from that, researchers would randomly select a pre-specified number of clusters and then randomly select a pre-specified number of participants from each of those randomly selected clusters. And on the bottom here, what we're looking at here is the city of Toronto, or the electoral map of the city of Toronto at the federal level. And what we have here are these different ridings at the federal level. And so cluster sampling is carried out in terms of obtaining polling information pre-election. And so polling companies, political consultants would use cluster sampling from randomly selecting from these different clusters a certain number of those clusters, and then randomly sampling people within those randomly selected clusters to ask questions about their preferred electoral candidate. One of the reasons that's done is that it cuts down on the resources that are necessary in order to obtain that pre-election polling data. And that's what cluster sampling is all about, and that's how it's used for elections. Now, the vast majority of sampling that takes place within research is what's called non-probability sampling, and as we've been touching on a little bit up to this point. Now, in conducting non-probability sampling, a convenience sample, as the term suggests, participants are chosen and entered into research studies based on availability. And this is one of the most popular methods that are used when obtaining participants to enter different research studies. One of the problems with the convenience sample is that the participants engage in a degree of self-selection. So those participants that enter studies are the ones that actually have an interest in participating in that study, which does carry some bias into that study. But once again here, that's one of the more popular methods that are used. Depending upon the research study and the research question, quota sampling is used when researchers have predetermined a set number of participants, and once that number, for example 40 research participants, has been achieved, then the researchers no longer enter participants into the study. They've hit their quote-unquote quota. Purposive sampling is where researchers now start to select individually those participants for entry on the basis of specified criteria. Now, this could pose some potential problems and issues because it does have the risk of researcher bias in terms of handpicking participants, but to minimize the magnitude of the effect of that bias, the specified criteria have to be very clearly articulated ahead of time so that the researcher doesn't incorporate their own bias into participant selection. Snowball sampling is, as the term suggests, snowballs from one person to another. So this involves chain referral. After one person has completed participation in one study, they would have casual communications or discussions, conversations with other people that they know, and refer those other people for participation in that study that they participated in. To carry out a study in the most valid way, it is important for researchers to understand that there are always sampling issues that are involved, and the goal of generating valid research is to minimize the effect of some of these sampling issues. The key term there is minimize because it's not always possible to completely eliminate these issues. One of the issues have to do with self-reports, and a self-report is where a research participant brings the information that the researchers are wishing to obtain into the study. So they're providing that information directly, and this occurs most often with surveys or questionnaires. One of the advantages of self-reports where the participant brings in the information is that it's very convenient on the part of the researchers. It's very cost effective and time efficient because the research participant is engaging in part of the information gathering process here. And it does provide first-hand experience from the participants. The first-hand information is being provided. However, there are a number of disadvantages with self-reports that researchers should be aware of. The first has to do with social desirability concerns, that if the research participant is providing the information directly if they're gathering the information and providing it to the researchers, some participants may wish to provide information that makes them look good, that where they are viewed in a favorable light by the researchers, and there is certainly that tendency. And we see that with questionnaires that report physical activity level, a grade point average, dietary recall over the previous week, and so social desirability concerns are an issue when we have these sort of items that have the potential for characterizing a person's some person's qualities. And the other issue is that there's no verification of these on the part of the researchers. The second disadvantage is what's called potential demand characteristics, and this refers to cues that makes participants aware of what the experimenter is expecting. And so by participating in a study, a participant may have an idea or formulate some perception of what the research is trying to ultimately achieve, and that involves that perception bias. And so objectivity can be lost with this type of concern. And one way to address this with the measurement instrument, so if this is a questionnaire or a survey, the questionnaire and survey should be free from what are called leading responses. And so that refers to statements that would tend to bias the answer provided by the research participant into one direction. Possible retrospective bias is also a concern, particularly if research participants are being asked to recall activities that they engaged in. And these past events can be represented in an inaccurate way. If, for example, we're talking about dietary recall, so a nutrition-based study where participants are completing a food recall questionnaire on what they've consumed over the previous few days, those participants may consciously or subconsciously omit quote-unquote unhealthy foods, and in doing so that would not result in accurate information conveyed to the researchers. If participants experience previous trauma, one such example are people that have experienced a motor vehicle accident. And the problem with recall here is retro or antegrade amnesia, particularly if those motor vehicle accidents were very serious and involved a head injury. The person may not recall certain activities that led up to the accident, which is retrograde amnesia, or the events after the accident, which is called antegrade amnesia. And so this does pose a problem with the accuracy of information if this is part of a research study. And so the way to deal with these disadvantages is to ensure that not just the testing instruments, but the testing methods in which those instruments are deployed should have a degree of acceptable reliability and acceptable validity. It's also very important that researchers understand that reliability and validity of those methods and those instruments will not be perfect, but it should be of a sufficient high enough level that it would provide confidence in being used in further studies and confidence that the information gathered from those methods are valid. So this ends this lecture on sampling issues.